In today's video, I'll be introducing you to our latest 4-parallel fixed bed testing unit. This was particularly designed for ammonia cracking. Ammonia is a promising medium for transporting green hydrogen over long distances because it can be done at low pressures and it's a liquid. The challenge in this case was ammonia cracking is done at very high temperatures, up to 800 degrees, and to make it economically attractive has to be done at high pressures. This unit was specifically custom designed to do that. What we have here is the feed side of the reactor. We are generating on the back side of this unit a pressure head of ammonia, keeping it in the liquid phase with a leva pump. And then we're using Coriolis mass flow controllers from Barg to be able to dose very precisely continuous ammonia flows to each reactor. If we want to shift the equilibria or purge, we have the ability to co-feed nitrogen and hydrogen via the thermal MFCs here. And what's particularly interesting is we also have the ability to add in a controlled way very minute amounts of water for poisoning studies. That's what the Knauer pump with the water feed vessel is used for here. And here we're using ultra low flow thermal mass flow meters from Bronkhorst. As with almost all of our units, we have a fully integrated online GC, which is used for analyzing all the products coming out. On this side of the unit, we have the oven. The large convection oven is used to make sure that we don't have any condensation in the unit. It's pretty standard in all of the ILS units. And here we have the multi-zone ovens, which are used for performing the ammonia cracking reaction. There's two different types of reactors that are used here. One is a basically VCR connected unit, top and the bottom, which uses metal reactors, full metal reactors, often representing what will actually be done at large scale. What we also have is here the ability to work with a quartz-lined reactor. The advantage there is the quartz-lined reactor exhibits zero blank activity, which is very important because at 800 degrees, or let's say above 400 degrees, the nickel-containing metals that we're using for the pressure vessel reactors start to exhibit higher and higher blank activities. So the quartz-lined reactor brings that down to essentially zero. And what's also quite important in this unit was we needed to be able to remove any water, as water is the primary impurity in ammonia if you buy it. So we have absorption columns upstream of the reactors where we can pull that water at very low concentrations out of the ammonia feedstocks and then add it in a controlled way back in for poisoning studies. So really making sure our baseline is zero and then adding in ppm amounts of water in a continuous way very accurately. If you'd like to learn more about how ILS can help you with your green hydrogen testing or ammonia cracking testing, feel free to contact us, and thank you for listening.